Hello and welcome to Into the Terminal. Today we're going to talk about troubleshooting boot problems. So you'll recall that in our troubleshooting episodes, we're going to start the critical path with our tools that we're going to use today to help with the troubleshooting. And then after the transition, we'll actually go through some real life scenarios that Nate and I have seen in our careers that have surprised us and have had to troubleshoot. So why don't we jump into the terminal and we'll take a look at our first batch of tools. So a lot of the times when you're troubleshooting boot, and we'll actually kind of go through a whiteboard of what a good boot or what the process of boot looks like. But a lot of times what I found is there's file system problems, and that's what causes you to have problems booting. And so I know that we covered file system troubleshooting in episode 111 and 112, but we're going to be using some of those tools again today. So things are mounted, they're disk free and disk full, as well as where they're mounted. Uh, the last thing is um, the ones to look at our block devices. So fdisk-l will list the file systems on your attached devices. And then we also have things like lsblock, lsblk, list your block devices in a tree format, and blkid will show you your block IDs of the different block devices that are being used for your system. So we've covered these in the past, so this is a real quick run through. The new commands that we're going to use today, we're going to use fsck. fsck is file system check. You probably want the file system to be unmounted when you run it, but we could do something like,
I don't always check my file systems, but when I do, they're live.
right. And so it actually complains that you can't do it live. So let me unmount this guy and try it again. Right. So it checks the file system state. Uh, and then if it's a dirty state, meaning it was not unmounted cleanly, it can do additional things like verify the consistency of the file system. It'll look at the inode tables and see if there are any files that look like they were incorrectly removed from the system and may be able to recover them, which is actually why we have the lost and found directory in the top level of our file system devices. All right, Nate, why don't we pass it over to you and you'll take a look. Oh, actually, never mind. I have one more. Grub install, because what is very important when booting the system? The bootloader is really important when booting the system. So grub install, grub2 install. And we got to tell it what disk.
Yep.
So this will take our grub configuration file that is in boot and translate it into a master boot record or EUFI BIOS stored boot record for our machine. And we'll talk a little bit about how that works when we go through the boot process. But grub install will forcibly install a new configuration for your machine for booting.
It also puts some machine-specific files into /boot, which I discovered while preparing for my later demo, which is going to be a fun one.
I can't wait to see it. All right.
All right. So our next tool related to boot is Dracket. Now, Scott and I went back and forth on this tool because there used to be a tool called MK initrd, and apparently my memory is remembering up to RHEL 5 because that's when this changed. But Dracket does what MK initrd used to do, which is to make a new init ramdisk, which I'm sure you're going to talk about in your whiteboarding session, Scott. And then the last thing I wanted to talk about was rescue mode. We also have a a knowledge base article about how to use Dracket. I don't have a demo for it prepared, and to be honest, the knowledge base article covers it pretty well. So I don't know if producer Eric can share that on the screen. But the next thing I wanted to talk about was rescue mode, which I am going to use quite a bit today. There's two ways to get into rescue mode, and my demo is going to show you how to get into one of them, and my demo later is going to use the other one. So just there we go. All right, so I've got a booted RHEL 9.4 system right here. You can see. Sorry if the font size is a little small. It's hard to do in these virtual consoles, but we're just going to reboot it. All right, so reboot. And what you'll see is in the console, when you get to Grub, there's these two boot items, right? The first one in the list here is, of course, the default boot target. That'll boot your normal RHEL system. And then this rescue system is, I didn't look into exactly what all the pieces that are removed from here are, but it's meant to be a stripped down boot entry that is also separate from your normal OS boot entry, which can save you in some circumstances, depending on what sort of failure you're hitting. So if I hit that, it'll boot into a system that feels very much like my live system. I think it skips some services. It might skip some drivers. But the important thing is that it's a different boot entry. So if you somehow hosed up your primary boot entry, you can go to the rescue boot entry to get the system booted and fix whatever you broke. So, and then the other way to do it is to boot off a live CD. Sorry, go ahead, Scott.
So the reason that this booted up is it didn't have any problems. So it used the rescue kernel, but all the other parts of the boot procedure were working just fine, which is why you got to this console and you can log back into the machine. But if you are having problems booting the machine, it'll actually fail. And we will do several of these today where it like dies in the middle of booting. But what's unique about rescue is that the initial ramdisk image that comes with the rescue kernel has a whole bunch of tools and applications in it to help you troubleshoot and repair those problems. So even though it'll crash out kind of in the middle of the boot, the initial ramdisk image provides you a bunch of applications to help troubleshoot and repair the problem that would not normally be in the initial ramdisk image for a normal system.
I actually found that on a number of different ways to install RHEL. Like if I built an image using Image Builder, that rescue kernel isn't even listed. So I don't know if there's an option you can turn it back on. Maybe that's because it's designed for cloud deployments where you generally won't be able to boot to a rescue mode. But if you install from the RHEL install media, you get it. So just something to keep in mind.
And that changed, I think, in Red Hat Enterprise Linux 8. Maybe it was, I don't recall it being there in 7.
I don't remember when it changed, to be honest. I expected it to be there and it was not.
Yeah, it was
because I usually build these from an Image Builder built image, and I had to go and install them manually to get the system I was expecting to have for my troubleshooting.
Right on.
All right, so yeah, that's rescue mode. The other way to get into rescue mode is to boot from the RHEL installation media and tell it to rescue an installed system, and I'll show you all about that in my demo later.
All right, so that's kind of our toolbox today. A bunch of file system utilities. fsck is new to us because it's going to help maybe repair a broken file system. grub2 install to install a new configuration into the boot record of your system. Dracket, we didn't really talk a lot about Dracket, but usually you would use it to create an initial ramdisk image when for some reason the initial ramdisk image that gets created by default doesn't include something you need unique to your system, right? So maybe there's a device that you need the driver for at boot time. You can't wait until after the machine boots and we load it as a kmod later off the file system. So things like HBA card drivers, because we stored files on them, as an example. So Dracket, and I don't think we'll actually build a new one today. And then rescue mode, because it gives you this in-RAM recovery environment that hopefully you can use to recover your machine when things are like really bad. So stay with us after the transition. Don't forget to hit that like and subscribe button so that we can know that you like things and make more like it. And after the transition, we're going to be breaking a bunch of machines and using these tools we just talked about to fix them. So stay with us. All right. So the other thing that's kind of unique about our troubleshooting episodes is we talk about what does normal look like? Because if you don't know what normal looks like, how do you know where things are failing to then focus your troubleshooting um, efforts on? So why don't we flip over to the whiteboard and we'll talk about what boot or what happens at boot time. So um, please bear with me as my art is horribad and no one pays me for my fantastic whiteboarding. But the first thing that happens in your boot process is your hardware initializes. So, right, your hardware boots up and you get like the vendor splash screen, right? And it's doing its power on self test. And that's independent of Linux, right? That's with the hardware provider. All right. But one of the things that's going to happen from that is it's going to figure out its boot device. And that's actually set in the either the EUFI settings or your BIOS settings. And so you can change the boot device, or it'll actually scan maybe a list of boot devices to figure out which one to use. And normally, whichever boot device it encounters first on that list is the one that's used, which is why in some things you might need to like reorder or choose a temporary boot device to force it to do something like boot off the Red Hat install media to get you into the rescue mode off the install media. But so your boot device is selected. And normally, that boot device would be something like a hard disk. So your boot device is selected. If it's a hard disk, it probably has a bootloader stored on it. Now, how this bootloader is actually stored is a little bit different between classic BIOS and EUFI. I won't go into the tedious details between the two of them, but essentially, in both cases, there will be a bootloader that gets executed on your boot device. And for us, Nate, what bootloader do we use?
We use grub, grub 2 to
Yeah.
be specific, which is why there was a grub 2 in that command.
So a while back, Red Hat Enterprise Linux and Fedora and all the Red Hat flavored distros moved from Grub 1, Grub, to Grub 2. All right, so Grub 2 has a small executable that's stored uh, at the beginning of the disk, which is actually what gets run by your BIOS or EUFI boot. And so we call that stage one. It's shocking that's its name. But stage one has enough
Shouldn't it
stuff in
start at
it.
0? What the heck?
Stage one has enough stuff in it to be able to load or read a configuration, so it knows what different things are on our boot devices, and it can access stage two, which lives in the slash boot directory. And it knows where stage two is because it actually has the like block address of where that executable lives stored in its stage one configuration. So it like goes into the boot file system and just executes stuff off of the disk without actually mounting or using the file system, which is kind of crazy. But that's one of the reasons why historically boot has been its own file system, its own standalone partition, is because in the olden times we had problems with things like being able to access those blocks beyond a certain place on the disk directly. A lot of those have been lifted, but we still kind of operate in the same way. All right, so grub, uh, we execute stage one, which will then execute grub stage two off of the disk. And grub stage two is actually what interprets the configuration for it, right? So this will prepare your menu. Right, so now you get to choose your list, and there's a timer that by default I think is 5 seconds, where you can kind of interact with it to change what kernel you're booting. But in that configuration is a couple of things. One is the kernel that goes with each entry. So when I pick this entry, there's a file in the boot directory that corresponds with that entry. And we're going to access that file and we're going to load it into memory as our kernel. So we choose our boot target, which is going to be a kernel. Man, let me try that again. And ramdisk. So there's two things that are in there. The name of the kernel file we should access and load into memory, and the name of the ramdisk file that goes along with it that we should access and load into memory. So those things get uncompressed into memory and they'll be initialized, and then you'll start seeing a bunch of kernel messages on the screen. After that, we launch process ID number 1. Nate, what is currently process ID number 1?
Now you're quizzing me here. Process ID number 1 is systemd or init. It would have been init. No, what are you writing there?
So what happens is the kernel, as part of this boot, is going to access the slash file system read only. And once it can access it read only, it's going to execute the systemd process. And like a gajillion years ago, that was the init daemon, but now it is systemd.
Unless you're not running systemd.
Yeah,
For
but
all those
like,
people who refuse to.
there's like Linux distros that don't use systemd these days, right? So maybe if you're one of them, you're still using init.d. All right, so systemd is executed, and then systemd looks at its configuration file configuration rather, to figure out the default target that it should boot to. And so for the systems that we're looking at today, that's probably multi-user target. That's what it's using. I, of course, am using
The
graphical.
wrong one. Yeah.
Yeah, because I believe in servers with GUIs, and not everyone does, and that's fine. So it's going to pick the default target. There's others too, but multi-user and graphical target are the most commonly used. All right, and then based off of that target setting, it's then going to go about doing a bunch of stuff to get the machine fully booted. So it's going to be
Right.
enabling services. It's going to be mounting all of the file systems out of the etc fstab file. It actually will also remount the slash file system read write. And it assembles your working system. And then at the very end, it starts up the console for you to log into. Well, maybe not at the very end, but that's one of the last things to get invoked by systemd is
Yeah.
to have
The
the
user
plugin.
interface.
Yep. So in the case of graphical target, it'll be the graphical login screen gets presented. In the case of multi-user target, it'll be one of the TTYs that sit there at the text console so that you can log into, right? And so this is the order of things that happen on your machine at boot. And so if you know that this is the order of what's happening, if something blows up, like right here, right? So you see the kernel and RAM disk get mounted and run, but then like the wheels fall off. Well, you know it's going to have to do with something about accessing slash and invoking systemd, right? And that's where you should focus kind of your attention. Or it might be something was wrong with the kernel and RAM disk that was loaded, but like on either side of that what's supposed to happen, and so that's where you're going to focus your troubleshooting, right? If instead systemd is executing and you see all the services starting and then it falls off, well it's somewhere in here where the target was selected, and then we started to start all the services and do all the things to get the machine booted, and that's where we fell apart. So we don't then have to look at kernel and RAM disk because that's in the past. Instead, we need to look at things like what are the units being invoked by systemd? What are the error messages being left on the console to help direct our troubleshooting? All right, so that's the what good looks like. Any further commentary before we jump into a broken box?
I think this is a great diagram because you and I were talking before the show. A lot of times when you go into these whiteboard sessions, all my experience as a systems administrator, I get a feel for how these things work, but I don't necessarily have a list of all the items. And mine was pretty spot on, even just from experience. So I feel good about that today. Sometimes I learn stuff from your whiteboarding sessions.
All right, so let's jump into to my machine terminal, and we have a problem already in existence. So everything looks fine. Look, I can run a command. Everything's
Everything's great.
cool. Yeah, it's great until we reboot, and then the wheels are going to come off. So there's my my BIOS. I should see my grub screen next. Oh, it was too fast for us to catch. So
It
now
went
we're
too
getting,
quick.
yep, kernel and systemd messages. Now, because I chose graphical target, it's got this little thing where it's actually just like showing me that there's a progress screen. But if I hit escape, it'll turn off the graphical screen and it'll actually give me the console messages that are happening on the console. So cool. We loaded kernel stuff. We mounted /boot, and here it's going to kind of like have some problems. So
So if anyone's curious, that graphical boot that Scott had to turn off, if you run in a server environment where you'd rather the console not be hidden behind you, that you can turn that off via kernel command line arguments. So just FYI, I think it's the RHGB tag that ends up at the end of the kernel line. So you can remove that, and then you'll get this text mode at boot. Just FYI.
yep. And it'll save you a little bit of extra memory. Not much, but a little bit, because you're
Yeah,
not
I don't know
having
if that's why I was thinking. I'm thinking more like if I'm a systems administrator and I'm standing at the console, I don't want to have to hit an extra button just to see what's going on.
That's right. I like my text to scroll.
Well, no, I mean I've run
Uh,
into cases where like you plug in, like you switch to the console for via your KVM, and like maybe your keyboard and mouse isn't responding because they weren't noticed when the thing booted, and all you have is this graphical thing, and you can't hit escape because the keyboard isn't recognized. Anyway,
yeah.
I'm a belt and
All right.
suspenders kind of guy.
So here we are. Machine has crashed. And what we get, look at that like red message. It says time on it. It timed out. It
Yeah.
says timed out waiting for device dev mapper rel-dat. And then it says, there are a couple dependencies that failed, and it was in the mounting local file systems task
Hmm.
that systemd was doing. So all this diagnostic is like telling me, where do you need to focus? So we were mounting the local file systems, and then we broke. So I'm
Yeah,
going to
the one
focus
that
on,
yep, the one that it tells you right there, the one that failed slash data, right? So you have something to go on there, and it tells you
yep,
which device it had trouble getting to. Dev mapper
yep,
rel dash dat.
right. And because we had the machine booted and systemd was able to start, and systemd mounted the slash file system read write, we have like a half working machine. And so what we're getting here is uh, a prompt to put in the root password on the console to get dropped into a recovery mode where I can try and fix this problem. So this is my machine, but it's not fully booted. It probably doesn't have networking yet. Um, it may have some of the file systems, but not all the file systems, but at least it has slash accessible. And then notice it says, or press Control D to continue. Yeah, you don't want to do that, because when I hit Control D, it's just going to reboot the machine. And then we're going to go through the same set of steps, and it's going to fail at the exact same place because I haven't actually fixed anything yet. So, it's
You
tempting to
can't
hit
just turn it
Control
off
D.
and on again?
Right,
I thought that's
exactly.
how you fix these things.
It is misleading to think that you can just like, oh, Control D, I'm all good. No, you're not all good. All right,
I
so
should
let
have
me put
brought
in.
my. I have a mug that says, "Have you tried turning it off and on again?" I should have brought that for today's episode.
I mean, it is the IT go-to. All right,
Yeah.
so uh, I have my machine, and I can do something like df-hp, right? And I can look to see what my file systems are. And so I have slash, I have boot, but I don't have this thing that it was complaining about, which is slash data. And so what I'm going to do is I'm going to cat etc fstab. And we can see down at the bottom, there's a listing for slash data.
Hmm.
And the complaint from earlier that's now scrolled off the screen was us having problems accessing dev mapper rel-dat. So it's
Yep.
a logical volume that is having problems. So if I do a LVS, there's my list of logical volumes that are recognized. And notice
Mm,
that one there is that. And yet when I look in the etcfs tab file, it's missing that last A. So the reason
right.
it's not able to find this file system is because the device that I told it the file system lives on doesn't exist. So it can't find it to mount it at the mount point. But when I look at the actual list of logical volumes, I see there is a device called data. So let me go into etcfs tab and we'll just fix the name to be correct. And then we'll exit the shell. So now that we exit the shell, it continues the boot process.
With your graphical login.
That's right, because server with GUI is the way. As I see producer Eric's eye twitching like crazy. Um,
This is into the terminal, Scott, not into the GDM.
all right. Um, yeah. All right. So notice that when I exited, it retried the thing that had failed, the local file system mount. And now it's able to successfully mount data. And we're able to continue on and boot all the way up and everything's recovered. All right. So I said that this is a real life thing. And this happens all the time. You create a new file system and then
Yeah.
you put the entry into etcfs tab, right? Because you like create the file system, you mount it, you make sure everything's good, and then you put the entry into file fs tab so that when you reboot, it gets automatically mounted again. Except, here's what you forgot to do. So you went to etcfs tab and you made a typo, but you didn't notice the
Hmm.
typo because you just did it by hand. You were like, that looks right, cool. And then you will get to experience the wrongness when you reboot that thing 2 months in the future when you're doing
Yeah.
a reboot for an update or something that you
Yep.
did. And
Why did the
you have to
update break my system? No, it's the thing you typoed 2 months ago. Yeah.
exactly. So here's how you stop from having those problems. So you put the entry into etcfs tab, and now you want to verify it. So what we're going to do is we're going to umount data, right? So now
Hmm.
it's not mounted on the machine, and then we're going to do a mount-a so that it will. Oh, and we have to fix systemd. Thank you, systemd, for telling me what to run. All right, let's try it again. Mount-A. And now we get an error. So at boot time, we're trying to mount all the file systems, which is what mount A does. Um,
Hmm.
it experienced an error, right? Well, here's the same error, right? We can't mount slash data because the device dev mapper rel-dat doesn't exist. So you can go back in and fix your problem now while you're working on it already, so you don't have to remember what you're doing 2 months ago that caused this problem. So we can go into etcfs tab, fix our problem, reload system D again. And now when I run the mount-A, it mounts
Ta-da.
cleanly. Yep. And I can verify that that device is mounted and everything is good. All right. So that's our first problem. Typo in etcfs tab happens all the time. Now we know how to troubleshoot and fix it. Nate, are you doing the next one?
Yes, I am doing the next one. All right. So I've got a system here that's already Like I just turned this on in preparation for the demo, and it's already not booting. And Richard was in the chat talking about we don't see any kernel panics yet. Well, here you go. Here's a kernel panic. I know it's cut off a little bit by our cameras, but you can see it right there. Kernel panic. So I'm just going to quick give this a reboot to show you guys what it's going to look like, because it does give us some information before it got to this point as to what the problem is. So we're going to click reboot here. Oh, that's not going to work. Hold on. I got to force reboot. There we go. And here, right, plain old grub. Just going to let it time out. And right there, it tells me it can't find the initramfs. If you remember Scott's diagram from earlier, that's basically like the next step in the chain after it's loading the kernel, right? So here we are, kernel panic because of not being able to find the initramfs. Now, we talked about rescue mode before, right? Sometimes if you can't find the initramfs, it could be a really, really big problem, like there's data missing, or it could just be a simple typo, right? So in this case, we're going to do that force reboot again. And remember I said about this second option here in the grub bootloader for rescue mode? We're going to try that first because it's so much easier than having to go, attach a RHEL DVD and connect that way. So let me just adjust this so you can see the console better. And here we go. Now, rescue mode, assuming it's not also impacted by whatever problem, and you can see already it's booting better, right? This will get us to a booted system, which, maybe you'll just be like, cool, it's up and running, we're good to go. But no, we have to go find the actual problem. So we're going to log in as root here. And now, if you were quick enough to catch it, right, it tells you the name of the file it's trying to find from the boot command or from the grub command line. So what you could have done is jotted that down, whatever, and then you can go look and see if that file exists. Those files exist in /boot, right? So in /boot, you can see there are definitely initramfs in there. And if you had jotted down the version of the kernel that we were dealing with, it's 5.14.0, 427.13.1, you'll see, in fact, there's an initramfs right there for that kernel. So why won't it boot? Well, I don't know how well you can see this in the stream because of font sizes and whatnot. You can see there's a typo in the initramfs file name. There's 2 dots between the 13.1 and the EL9_4. So the grub bootloader told us it was looking for initramfs 5.14.0, 427.13.1.el9.4, but here the file name has 2 dots in it. So all we really have to do is rename that. Now, obviously, this is sort of a contrived example, but if for some reason you were doing something like building your own initramfs using Dracut, it's possible that you could have built it and put it in place and then either not updated the grub configuration properly to point to the right file name, or you could have named it slightly differently than the system expected when it generated the grub config, right? So that's 2 ways that this could have occurred, right? So we're just going to go and fix that. initramfs 5 with 2 dots to initramfs 5 with a single dot. Can I go back? Tab auto completion makes this so much easier to type. And now if I reboot, it should just come right up without me having to go into rescue mode. So this is a great example of how that second item for rescue mode is really handy. You could have also, if you're on a system that has had the kernel upgraded more than once, you'll have old boot entries in there for the old kernels. That's another great way to get into a system that won't boot. So if you're making changes to the most recent kernel and it won't boot now, you can boot the one from the last update, right? So, whatever the most recent kernel is before the changes you just made. And there you go. My system's up and running again.
Awesome. So you ran Dracut, you made the wrong file name and blew it
right.
up.
I mean, you can imagine there's lots of use cases as to how that file might have gotten out of whack. Maybe you were changing the grub config manually. Maybe you were generating a new initramfs and you just made a simple typo, like having 2 dots instead of 1, like I just had there.
Yeah. So if we switch back to mine, we'll have another machine that's busted.
More
All
broken.
right. We're going to boot this machine. And so we see the kernel load and it's starting to run. And actually, I'm going to escape here so we can watch the thing. System D has started. Everything's good. We're mounting local file systems and we get some failed stuff. And then another file system problem.
Emergency mode. Oh no.
Man, I terrible file systems today, Nate.
Yeah.
All right.
Yeah.
Put in the password to go into maintenance. So again, no networking. Some of my file systems are mounted, but not all because we were having problems mounting them. So why don't we cat etsy fstab and see what we should have, which is slash data and mount. And then we'll do a df-hp. This is what we do have, slash and data. I don't see slash mnt mounted. So let's just do that. Boom. Mount dash A, it actually hits that line. It knows that that's the thing that's not mounted. And it says, nope, can't open dev SDA2. All right, so
That's a
let's do,
problem.
yeah. All right, so let me take a look at dev SDA2. So Etsy fstab says dev SDA2 should be mounted at slash mnt. It's an ext4 file system. So that's weird. Unknown file system type.
Oh
Hmm.
no. You've totally hosed your file system.
So this is what things look like when you have file system corruption.
Yep.
And there's a bunch of different ways that can happen, but thankfully they're relatively few or they don't occur very often. But there is one tool that we kind of use to try and recover from file system corruption. So it is currently not mounted. So we're going to run fsck on devsda2. Oops, sorry, devsdb2. Man, if I use the right device.
That
So
helps.
goes through and says, hey, we're going to do these checks. And so we check the inodes and the blocks and files. That's all cool. We look at the directory structure. That's fine. We kind of navigate around the directory structure. That's fine too. We're looking at references. So do the things in our directory structure actually point to files on disk and can we find them? So if there's like half removed things, we can find that kind of stuff. And then here we go. Hey, there's some bitmap differences between what I think the size of the file system is and then what I actually see it on disk. So do you want me to
Hmm.
fix this? Yes. Oh, and by the way, the free block count is wrong for inode group number 1. There's a missing block. Do you want me to fix that? Yes. Uh, the free blocks are wrong. Yes. The inodes are wrong. Yes. Keep saying yes. In fact, like when you're asked any of these questions, they all look like questions where the answer is always yes, right? If I wanted to, I could have just called fsck minus y to answer yes to all these
Yeah.
questions so that I don't just have to keep typing yes.
I
All
always
right.
got iffy about that because what if it said, would you like to erase all the data? Yes. No, no, I didn't want to do that.
Well, the fsck never asks you that because that's not what it
That's
does.
true. That's true. But at 2 in the morning, if it did.
All right. So now that I have file system checked it and gone through and file system check has repaired all of these things that have found wrong on the file system, now let's do a mount dash A. Oh, and helps if I reference the right thing. It's not devsda2, it's devsdb2.
Oh, see that? You had 2 failures going on here.
Yeah, this is what happens when you put things in by hand. You just go, "Yep, that looks right."
Looks fine. Totally
That's
fine.
right. systemctl. Man, I am having
Pretty
a rough day
loud.
today. That's right. All right, let's try this again. Mount-A. Oh, it looks. No errors.
Hey,
F-HP.
you fixed it.
Here it is, mounted at /MNT. And if we reboot the machine, let's make sure that it all comes up and everything's cool. All right, so there's my kernel initializing. Now systemd is starting. Systemd is starting to mount all the stuff. It started all the services. Yeah, we're looking pretty good. Like this is where I crashed out before. And bam, server with GUI.
Just got to rub that
So
in every time, don't you?
I do. I got to twist the knife. So in that situation, what happened was the superblock on the file system had gotten corrupted. Now, I purposefully did that by using DD to overwrite it. But that's why things like the block count of the file system was weird, because the first portion of the file system had been overwritten with garbage. The superblock, which actually tells the mount command what the properties of the file system are and how to work with the file system, what file system format it is, that was corrupted and it couldn't be read. And so fsck helped fix all of those things that had gotten corrupted on that file system by me wiping out the first bit of it and its superblock. All right, Nate. What are you
Yeah,
working
I've got
on?
another horribly broken system. All right. So this one looks really bad, right? I mean, it can't find some data from grub core fshelp.c file, yada yada, and it's in grub rescue. Now this, I could reboot this to show you what's going to happen, but it really doesn't do anything but get me to this error, right? So basically, grub can't find any of the stuff that it needs to find. So we don't have an option to go to rescue mode from grub because grub isn't even fully loaded at this point. Basically, grub's got no config to reference. It's got none of the files that it needs to talk to the hardware. It's just it's got the very basic grub bootloader that it got from the boot sector of the disk, and that's it. Right now, in a situation like this, I mean, start to panic. Your server is down. Grub's giving you no options. There's probably some stuff we can do within the grub rescue environment to try to do some troubleshooting to try to identify what's going on. To cut time a little bit short, I already know what's going on. So we're what we're going to do is we're going to actually boot from the boot DVD, or actually the binary DVD for RHEL 9.4, which is exactly what I have running here, right? So first, we're going to force a shutdown because this thing is not working at the moment. And since this is a VM, I have to go back over here, click Insert for a DVD. Libvirt, right? ISO's RHEL 9.4. Okay. We're going to click insert there. I've already got this set up so that it will try to boot from the DVD when I click run here. So I'm going to click run and get down to the console as quick as I can before it tries to do an installation. All right. So let me get the console a little better in view here. There we go. So this is what you'll get when you boot off of a RHEL 9 installation disk. Now, obviously, the default is going to be, I want to test the media and do an installation. Well, we're not there yet. We don't want to reinstall this system because we don't really know what's wrong with it yet. There could be data in there that we can resolve, that we can recover. There could be a way to fix the problem that we're seeing. Okay, so we're going to go down to troubleshooting. And in troubleshooting, there's a couple options here. We can install with text mode. That's basically if you have video issues in the graphical mode installer. We don't want that because we're not trying to reinstall. We're going to do rescue Red Hat Enterprise Linux system. Now, you can see there's also things like a memory tester here. You can tell it to boot from the local drive. Again, good tools to know that are here, but not useful for today's example. So we're going to go rescue a Red Hat Enterprise Linux system. And this is going to boot just basically a live environment from the DVD. And it's going to let us mount the disks that it sees on our system. Now, if it can't find your disk, you're in a worse boat than we are for this particular demo. But you still may be able to use some tools to see what's left on your disks, try to identify if there's any data you can recover, things like that. But first, we're going to try to recover this particular system. So you can do a read-only mount if you're worried about writing changes to the disks that might cause damage. We're not going to do read-only today. We're going to just hit number 1 to continue. What number 1 is going to do is it's going to look for partitions. It's going to look for logical volumes. It's going to look for an etc fstab. And if it can find those things, it's going to mount them under mount sysroot, right? So we're going to do number 1, hit enter. Now it's going to start doing that scanning and stuff, try to figure out
And I
what's
think
going on.
the mount sysroot thing is, I think, what causes people the most problems with rescue. So
Hmm.
Nate put it where he said it loads a live environment into memory. And
Right,
so in that environment, there will be a file system, there will be tools, and then your box is going to be mounted at this other location inside of the live environment, which is mount sysimage. Right. So if
right.
we just, yeah, you did an LS at the top level, it looks kind of like a Linux box,
Yeah,
but that's not your Linux box.
right. So this is the live environment. If I go into mount/sysimage, oop, and do an ls, this is my actual environment, and the console is not cooperating with me. It's a little too tall for the live stream, but you can see here that we have what looks like our actual Linux file system here. Now, what it was complaining about was files that it couldn't find inside of boot, right? Or I should say inside of grub, but we know that the files for grub live inside of boot, right? So we're in mount sysimage now, right? If I do a pwd, you can see we're in mount sysimage. You can also use chroot, which I'm going to do in a minute, to almost emulate your live system. So if you want to make changes to the system as though it is your system, you do a chroot into mount sysimage. But we're not going to do that just yet, or mount sysroot, because we're still in like a diagnostic mode at the moment. So we're going to go to boot because, like I said, it found boot in my etc fstab and it mounted it here. If we do a mount, you should see it. Well, here, let's do a df. We do df. You can see under mount sysroot, we've got mount sysroot boot, mount sysroot boot EFI, mount sysroot dev, mount sysroot home, temp, var. Those are all the partitions that I have in my actual environment. So, okay, so from here, we're in boot. Oh no. Boot is looking suspiciously empty. All it has is the EFI volume, which is where the EFI configuration exists, so that if you've got a UEFI BIOS, it can read that. But because boot is empty, now you might remember from my last demo when we were looking at that initRD, things live in here, like the initRD, the kernel, a bunch of really important things to make your system boot, right? So boot is a pretty important partition.
Grub stage 2, the
Yeah,
configuration.
yeah. So luckily, what boot does not have usually is variable data, data that you may have created that's hard to replace, right? It's got the kernel, which is something you can get from your installation media. It's got the grub binaries and whatnot to make grub work. It's got the config for grub. It's got the initRD. These are all things that you can either reinstall or regenerate, right? So we're going to go through and do that, and I'm going to show you basically how this works. So because now I'm going to caveat this. I have specifically crafted this environment so that this is easy for this demo. If you're on a system, this is a fresh 9.4 install. I've got the 9.4 DVD attached. Okay. If you're on a system that is not completely fresh, which you probably won't be, the version of that kernel is going to be newer than what came from the DVD image. At that point, you've got choices. You can either revert to the one that came from the DVD image, or you'll have to go get the version that was running on your system, which maybe you know, maybe you don't. Your grub, well, no, your grub config is gone. I'm trying to think how you would know. The RPM database should be able to tell you what was installed, right? Which you can do, by using chroot, you can then use RPM to query the RPM database and say, what packages does my system know about? It'll still think the kernel's installed even though the files are missing. And then you can reinstall the RPM if you have it. In my case, I have it on the DVD. In your case, you may not. In which case, there's things you can do, like if you've got local repositories from satellite, you can get those mapped into the system. I did try to see if I could get my rescued machine to talk to the normal Red Hat CDN to get data, and I was having a hard time getting it to do that because subscription manager and DNF were not happy with the environment that I was in. Maybe with some more work you can make that work, but just keep that all in mind as a caveat.
So Nate,
all right, so we're gonna go. Sorry, go ahead.
One quick question. If I had a backup of my boot file system's contents, could I just restore that backup here?
Yeah, you could restore the backup. You'd probably, and at the end of this, we're going to do a grub2 install to get grub to refresh all of its files. You may or may not have to do that because the files that it replaces may be included in the backup, right? I haven't tried that, so I can't say for certain. You can just restore and go. You may have to restore and then do a grub2 install. So, all right. So like I said, I've got the DVD image. It's already attached to the system. It puts it in /run. What was it? Repo? No. Install. No. Where is it? Yes, install. Repo. That's the contents of the DVD image. And I realize we're cut off by the cameras. I'm sorry. There's not. I guess I can do this and show you again. I'm having trouble with the console size here. There we go. So you can see there's the app stream RPMs and there's the base OS RPMs. Good stuff. But how do I actually get my rescued system to use it? I could just go into those directories and do an RPM reinstall on the specific RPMs that I care about. The problem is dependencies are difficult to follow with the RPM tool directly, right? DNF makes that a whole lot easier. So it's a lot cleaner if I can use this DVD as a DNF repo, which, surprise, you can, right? That's exactly how the installation works. It sets up a DNF repo from the DVD media, and then it lets you install from that. So let me just get back to my notes here so that I don't mess up the scenario here and I don't waste everybody's time. All right, so the first thing we're going to want to do is we need to make sure that this installation media is available from within mount sysimage, right? Or mount sysroot, sorry. No, it is sysimage. So we're going to use mount. We're going to use a bind. Now, there's other ways to do this. You could probably symlink it, I think. No, that wouldn't work inside of chroot. The mount bind is probably the cleanest way to get this to work. We're going to bind /run /install /media. No, not media. Repo. to /mount sysimage. I guess we'll put it under mount. Okay. And what this is going to do is it's going to make a link between those two, right? It's I don't know if hard link is the right word here, but what it's going to do is inside of my file system, all the calls that go to mount sysimage mount are effectively the same as run install repo, right? Now we're going to use that chroot command, which we can argue about how to pronounce chroot. I know there's a lot of different ways. Chroot, whatever. Change root. We're going to chroot into mount sysimage. And now, if I do a pwd, it looks like I'm in slash. ls-l shows me the data from within my system that was mounted, right? And if I look inside of mount, there's the contents of the DVD. But it's not a repository yet, right? Now, what you can do is you can manually create a repo file, but there's this media.repo right here inside of the root of the disk here. If we do copy mount media.repo into etsy yum.repos.d, and then we're going to have to edit it.
And while you're doing that, Nate, I just wanted to, we said root into mount sysimage and then kind of glossed over it. But what we're doing is you're creating a subshell where it is
right.
its environment inside your subshell is constructed such that it can only access what's in mount sysroot. It can't go outside of that directory structure. And so you've changed the root of the file system for that shell, hence the chroot, to mount sysimage, and that's you're like locking it down in that sub environment for your subshell.
Right. So what I've done is I've added a line at the end, and again, my console is a little bit bigger than the screen here. Let me scroll up. I've added a line to the end, base URL equals /mount /baseOS. BaseOS is the repository for BaseOS. I don't need the AppStream repo, but if you needed one, you could make another copy of this, give it a new name, and also do AppStream. But for this particular repair, we only need BaseOS. So we're going to save that. It's read only because I copied it from a DVD and it didn't copy the read write flag. But since I'm root, I can say write it anyway, dang it. So I did. All right, so now if I do a DNF repo list, we should have a repository called install media, because that's what it was called inside of that repository file. So there we are. Now we have the ability to do installations and whatnot. So what we're going to do is do a DNF reinstall. So reinstall basically says, hey, there's a package already installed. I'd like to reinstall it from my repository. What that's going to do is it's going to find the version that is installed, find the version in the repository, and reinstall that specific RPM, right? We're going to do a DNF reinstall on kernel star, which says any package. I think it's any installed package with the name kernel. It should be any installed package with the name kernel. And then we're going to do grub 2 -star. And what that'll do is any grub2 package. Now, you probably don't have to do all of them, but I didn't go through and find exactly which ones I need to reinstall. And this isn't going to hurt anything, right? So what we're going to do is just make sure I didn't miss any here. I think that's it. It's going to do a reinstallation on all those packages. And you can see there's grub2 common, grub2 PC, yada, yada, yada. Then there's a bunch of kernel core, kernel modules, kernel tools. We're just going to say, yes, go ahead and do that. And the cool thing is when you install a kernel package, it also does things like regenerates the initRD. And when you reinstall grub, it's doing things like reconfiguring that grub config file, which is also something that's missing that's inside of boot. This is all running within those scriptlets that run after the package installations.
And actually, Nate,
we're almost done. Go ahead.
A great segue. Our next episode, we're going to be talking about package installations. So scriptlets, man, there's something not many people know about.
Good old scriptlets. So yeah, it's probably building the initRD right now. So let's give it a minute. But once this is done, you might think, hey, we might be ready to reboot. I've installed the files, right? Well, there's one more step afterward, which we did talk about earlier, if you're remembering. I tell you what, before this episode, we tossed around the idea, what if I just delete boot? You think we can recover from that? Scott didn't have any faith in me.
That's not true. I always have faith in Nate. I just think it's arduous and man,
Just
it would be
kinda...
nice backup to restore from.
Oh yeah, a backup would be a much better way to recover this particular scenario. But if you don't have a backup, because who backs up boot? Who would back up?
Well,
there's no data in there I care about.
Yeah, and so like the places where this actually happens, like everybody's like, why would you remove boot? You don't do it on purpose.
Exactly.
You were DDing and you accidentally DD'd over dev SDA and figure that out and were able to control C it, but you've corrupted boot, right? So you have to like look your file system on it, and then you got to recover all the stuff that's in it.
All right, so let's see what we got now. We do an ls-l on /boot, and look, it's looking really handy now, right? This looks like we're done, right? We've got the grub2 direct subdirectory back. That's where it said those files were that it was looking for. It's got a config and initramfs. It even restored the rescue environment that we were talking about earlier, right? You can see all the stuff is there. System map. If I were to reboot now, though, it's going to give us the exact same error. And the reason for that is I didn't do a grub2 install. Now, this may not be required for every particular scenario, but in this case it is, because I've basically wiped out a bunch of stuff under boot, which is generated by the grub2 install. That boot sector is probably still there. In fact, we know it's still there because grub tried to load before, but the supporting files are not, and that's what grub2 install is going to fix for us. So in my case, this is dev VDA, and yeah. And it's going to basically figure out where the files need to exist, which is, I guess, included in that boot sector. I'm not really certain how it knows where boot is, but it does figure it out. And then if we do an ls now in boot, I think it's underneath, was it under loader? I forget which files it couldn't find. No, it's not under loader. It's under grub2. Yes. See this i386-PC? That's the files it couldn't find before. And I should have showed you earlier. They were not there, and now they are. All these files get written by the grub2 install. And at this point, we can reboot the system. So we're going to exit the chroot environment. We're going to shut it down. And yes, I just typed init0, even though that's kind of old school and not required. We're going to disconnect that. Sorry, go ahead.
If you exited the shell, it would kick off a reboot, but I know that you don't want to reboot it because you actually want to disconnect the DVD.
Yeah, right.
Yeah.
So I've ejected the DVD image. Now we're going to run it again. See if I can get this up before it tries to boot. Look, grub already looks better. And here we go. As long as we got all of our T's crossed and I's dotted. Oh, it's going to do an SE Linux relabel because we booted into rescue mode. The system is smart enough to realize that. It probably wrote that auto relabel file, which a lot of maintenance processes will do. So it just did an auto relabel to make sure that all of our SE Linux contexts are good, and now it's rebooting. And it should boot right up.
The reason that's important is that while you're in rescue mode, the rescue kernel isn't running SE Linux.
Right.
So as you're like messing around with files and file systems, like adding those replaced packages, the SE Linux context for those files was not being written.
Right.
So when you reboot the machine into an SE Linux kernel or SE Linux enforcing kernel, it wouldn't know what to do with those files because it doesn't have any contexts. So the relabeling is really important to like make sure that everything gets trued up after running in that non-SE Linux enforcing mode.
Right. And there we are. System is booted again. We can go back to bed and silence the pager.
All right. So we did have one question that that I cover, and it actually is germane towards that last environment. So Fernando,
RHEL 6.
Yeah. So RHEL, we talked about how RHEL 8 and 9 started adding this rescue mode into the bootloader by default on our machines. But RHEL 6 didn't do that. So Nate, if you had to have rescue mode on RHEL 6, what would you use?
Yeah, so I mean, there's still two options. One is if you had an older kernel, you could probably still boot that using the scenario from earlier, right, where it was just a typo and it was just that kernel that was broken. But the other way is to boot off the DVD like I just did. If you boot off of the install media, you can still get to rescue mode. The procedure is a little bit different than what I just showed, but it's the concept is the same. You can boot it up, you can get it into that read-only environment, or you can make it scan and mount your disks the same way that we just did in RHEL 9 right here. I've done that as far back as like RHEL 5, and it probably existed before that. I just don't remember.
It did, actually. We have had rescue since the Red Hat Linux days, back in like the 90s and the aughts.
Right.
But one other note, RHEL 6, super old. Like, no longer covered in ELS.
Yeah, part of your recovery procedure, if your RHEL 6 box is down, should be to build a RHEL 8 box, at least.
So I think that is it for questions. Been watching the chat. Red Hat Enterprise Linux points out Happy Sysadmin Day.
Yes.
So, great.
Should have started the episode with that, huh?
And then just our next step. So maybe you want to try to troubleshoot one of these problems yourself. So we actually have a link that you can try out, and it'll take you to a lab with very little diagnostics. It's basically the user saying, "Hey, this thing's missing. Can you help me out?" And you have to like explore and figure out what's there on your own. Um, so there's a troubleshooting scenario for you to try out if you are so interested. Um, it is a file system problem, just so you know.
Yay. Surprise.
That's right. So what's coming up? Um, First off, don't forget mash like and subscribe so you tell us that you like our content that we keep doing, and then you get notified when we are doing more of it. Next Into the Terminal will actually be in 2 weeks. We'll be
Yeah.
covering um, botched package operations. So like what happens when you install a package but it doesn't go right. So we'll take a look at that. This is pretty common, not pretty common, but it happens when you're doing things like upgrades and applying package updates. RHEL Presents, also in 2 weeks, is going to be covering Podman Desktop with AI labs. Oh, that's interesting. AI seems to be the hotness these days. So tune in to Eric and Brian Smith talking about Podman Desktop and AI. And then Eric is starting a new miniseries with Richard Rios, who happens to just be here in the chat, as though by magic. So on August the 8th, they're going to be launching a satellite miniseries. And it's starting off with installing satellite. So if you are new or interested in Red Hat Satellite, that's a great way to get introduced to the product. Red Hat Satellite miniseries starting August 8th with Eric and Rich Rios.
Yeah, good stuff. And just this past Wednesday on RHEL Presents, we talked to Yubico about passkey authentication on RHEL. So if you're curious about that, check that out too.
All right. So Richard has asked, what do you do if you inherit a Franken Linux host? I don't even know how. Was that like you combine RHEL and Ubuntu? Like, I don't even know what that
I
is.
don't even. I guess we would need more info, but we're already 40 minutes past our half hour, so I think we should wrap it up.
So any questions we didn't answer here, we will, of course, answer in the comments. If you're a deferred
Yeah.
viewer, please feel free to leave us a comment or a question, and we will answer it to the best of our ability. All right. So until the next time we see you at Into the Terminal, where we cover botched package operations, have a great time
Yeah.
terminaling.
Have a good one.